right, thank you everybody for coming. My name is Kevin Jones. I'm a developer relations. My name is Kevin Jones. I am a developer relations engineer working for the Graph Protocol. I am also a core member of the Build Guild. I'll be doing a workshop later tonight at around 9:30 on building with Scaffold ETH. But today, right now, we're going to be talking about the graph and how you can index your. Just kind of go and get started. So again, my name's Kevin. Please come find me after if you have questions. We're going to talk about what and why the graph is important. We're going to, from an architectural standpoint, the blockchain is kind of like this decentralized database that keeps track of a state of variables blockchain, right? Events. And so what we want to do is actually capture those events and index those events, right? But there are some problems with getting access to that data on the blockchain. First of all, there's lots going on. There's lots of protocols that are competing for block space. There's lots of transactions. There's balance transfers. There's just a lot in a given block, right? On top of that, the original data into your application directly from the blockchain, but that doesn't really scale. The RPC provider for a blockchain is really not designed actually. From a reading perspective, there is no incentive for the blockchain to really give you that data in a reliable way and quick way. So what we actually want to do is kind of replace this layer and still use the incentivization of the blockchain's consensus algorithm and the security of gas and writing transactions, but replace this read configuration. We also can't get historical information really easily on the blockchain, right? So we need a way to be able to go back in time and see exactly what happens at a particular time on the blockchain. So we actually want to do something like this, where we have this concept of like time machine, which I was really surprised to find out that time machine is still a thing. It's actually on my laptop. I did not know that. I never use it, but it is a really cool concept where you can go back in time, right, and see what happened to a particular file. Well, the same thing goes with the blockchain. You need to know over time what has happened, right, on the blockchain. And this is just not easy to do unless you know exactly what block number an NFT was transferred, right? So you end up having to do some kind of indexing. Additionally, like front ends are not really ideal for querying an RPC directly. This is an example of someone who wanted to get a list of all the NFTs in one wallet. And so this is great if you only have like 1 or 2 NFTs, but if you have hundreds, or like me, I think I have like almost 1,000 NFTs in my wallet, this would just completely make the application take forever to load, upwards of like 10, 20, 30 seconds. So we want to actually use the graph, right? The graph is a decentralized data indexing protocol, and it is built with values that are pushing forward decentralization and the access of that data. There's over 100,000 delegators, which are providing stake to the network for security. There's over 10,000 subgraphs on the network, which are like to those subgraphs to popularize them and whatnot. So we take this mess of a blockchain, and what we want to do is create what are called subgraphs, right? So subgraphs are these unique developer-focused APIs that people can be accessible way. So we can replace that kind of earlier method where we're kind of looping and going across the JSON RPC with a single GraphQL query. So GraphQL is one of the core components of the graph, and this is a optimized language, especially for like front-end applications, where you can specifically say what you want to get access to and get all of the results in a single query, as opposed to having to loop over like you were doing in this previous example. We also have this problem again where it's not incentivized for writes. So what we want to do is we're paying ETH, your gas, basically your way, to put your stuff on the blockchain. But for reading the data, you have this middleware layer. We're going to look at them in detail, but it's a manifest, which is a high-level config file. It's an entities, which is keeping track of how the data should be stored on the database and how it should be exposed with GraphQL. And then there's the third configuration, which is how we process the data. So you can imagine we need to be able to listen to these events as they come off of the blockchain, and we need to be able to put those into the database. And we do that with what's called a WASM module called assembly script. It's a subset of TypeScript. So it doesn't quite have all the full functionality of TypeScript, but it's really powerful. It's got type safety, and it's very performant and very secure. So as events come off the blockchain, we can process those in WASM, right? So we run these things called handlers, which take the data and process it and store it into a database. And this is exactly what the indexers are running. And then we expose that data for the consumer over GraphQL. So imagine all the indexers have a database running that's storing the data. but a consumer does not need to understand how to do SQL queries. They can exit point for all the data. We'll go back, figure out how to get the data, how to query it, and how to serve it to the consumer in a fast and reliable way. So this is what we end up with. We end up with a DApp. We still have our DApp that is written in HTML, CSS, JavaScript, right? Contract, or from the smart contract. They get picked up and processed using this WASM module right down here. And again, this is all written in assembly script. It's very similar to TypeScript. And all that data is going to be stored in a database. And then the graph node here exposes that data, kind of RPC method. We have a direct integration with Chainlink. They're here. So if you're hacking, you can get the graph bounty and you can get the Chainlink bounty in one shot, which is really awesome. So check this out. This is available on the Smart Contract Kit GitHub. Under functions, the graph Uniswap. And there's an example of how you can do Chainlink functions with the graph. So listening to the graph and running some processing, some functions. And the Chainlink guy is going to talk about this a little bit more. You might want to go over there and see his workshop. And then we also have a direct integration with Scaffold ETH. I'm going to talk about Scaffold ETH tonight at 9:30 in more detail. I'm having a full 1-hour workshop on how to do that. But today we're going to actually show this off if we have time on how you can spin up a subgraph with Scaffold ETH as well. And this is all done using this one single command. This will spin up a front end Next.js, a back end with either Hardhat or Foundry, and it will also spin up the graph running in this middleware layer for you. It's all Docker based, and we're going to set it up right now. Cool. There's also a Telegram chat if you guys want to get some help. You can join here. Obviously, we're going to be at the booth, and we're going to be in the Discord. But if you have questions, you can also scan this and get access. Okay. Cool. Let's do a live demo. We're going to just kind of go right away. So we're going to spin up a new instance. So we're going to do npx create-eth at project. -e is saying I want to use an extension, and I want to use the subgraph extension. So I'm going to use that. This is going to spin up my project. It's going to ask me what I want to name it. I'm going to call it Bangkok. And it's going to ask me what chain I want to use. So I can use Hardhat or Foundry. I'm going to go ahead and use Hardhat. It's going to scaffold this out for me. Okay. You don't need to know this, but basically we need to split up a couple screens. I'll go into this more detail at my next workshop at 9:30. But we're going to spin up our chain on the left screen up here, and we're going to spin up our front end over here, okay? And then we're going to use this other window down here to do our orchestration, okay? So I'm going to come down here, and I'm going to split this screen up as well, because we're going to need one more screen to set up the graph inside of Docker, okay? So this is a Yarn package, so it's super. We'll spin up your front end. Yarn deploy will deploy your contract. And then Yarn run will spin up your subgraph environment. So let's let that run. The internet's a little slow here, so let's see if it's going to finish soon. Hopefully it does. While it's doing that, let's go ahead and go into this folder on all these, and let's look at the code, okay? So go into there, Scaffold ETH project, and what's cool about it is it's got a monorepo style of thing. So it's got Next.js here, it's got Hardhat, and it's got the subgraph folder. So inside the Hardhat folder, it's just like any Hardhat instance. It's got the contracts. So it comes with a contract. It's kind of like a very basic hello world contract. And it comes with a deploy script already written for you to deploy your contract. So you're ready to go. Now, this contract is very simple. I'm only going to talk about it for a minute. But it's got a string called greeting. It's got an event that emits when the greeting changes. And then it's got a function that allows you to update. Down below here, we also have a Next.js package, which has a subgraph tab, and it has an example of how you can query the graph as well. So we use what's called Graph Client, which is a special SDK that's available from the Graph framework. So we have this kind of example of how you can like query the blockchain, query the subgraph. And then this last part is where the subgraph here. We got our blockchain, if I can type. Blockchain's on the left. Our front end is here on the right. Yarn start. And then we're going to deploy our contract over here. Yarn deploy. So again, where is it running at? Ah, here it is. Sorry, I had a previous instance running. Let me get rid of that. So yarn chain. and yarn start. There we go. Cool. So now I have the block because I deployed it to the old instance. So let's go do yarn deploy reset. There we go. So that's going to push my contract. Then I can come over here and spin up. Okay. So that way I can take my subgraph and deploy it locally without having to use a testnet or something like that. So it's really good for local development. Okay. So we know this is going to be ready when at some point it's going to say waiting for Ethereum blocks or like. And while that's doing that, let's go to the scaffold ETH. So scaffold ETH runs on port localhost 3000. And we're going to have to compile. And then now we have this kind of scaffolded environment. You can see there's this subgraph tab, which will tell you how to get your subgraph up and running. And we also have this concept of a burner wallet, where we can use this as a wallet inside of our application. We don't have to connect to MetaMask. Super handy because we can just grab some funds from the faucet and start signing transactions. So let's just send a greeting real quick. Let's say set greeting. So the other thing about Scaffold ETH is it has this debug contracts tab, which will let you automatically start wording types for your front-end application. So we can instantly come in here and start testing. I'm going to go into this much more detailed at 9:30, but we can come in here and change the greeting using this kind of built-in UI. So let's say hello Bangkok, like this. Hit send. There we go. So do yarn. Well, we can come here and look. We can go subgraph. We can do yarn run node is to spin up the Docker containers. Yarn local create is to create the subgraph. Yarn local ship is to deploy the subgraph to your Docker instance. And then this builds the assets if you need to, like if you've made changes. So let's run these commands, okay? Yarn local create. This is gonna basically create a very basic scaffolded subgraph for us. Then local ship is going to actually ship our subgraph. It's going to basically compile it. So it comes with a subgraph already written. So it's here in this kind of structure. So we have this subgraph configuration file that I mentioned. We have the source, which has the schema, the GraphQL configuration, and it has the mapping, which is the how network that you care about. It tells you what address you want to index. It tells you what entities that you want to save, how you want to store those entities. And it tells you what data types that you want to index. And then we process those again with the mappings file. So what this is kind of logic, okay? And we will basically save that data in the database after we set all the values for the entity, okay? So we import those entities up here as well. So these are all the types for the entities. So it's really easy to work with. If you know TypeScript, it's like super easy to write a subgraph. And then we have the data types for that data as well. And then we do some interesting stuff here where we link the data together with derived from. But let's try to deploy it. So we're going to put version 1. Here we go. Now it deployed it. So now we can grab this URL that it gives us right here. And we can load it up. And we should be able to see that data that we looked for. So if you go to Explorer, you'll be able to see the data. So we have all the greetings. We want to grab the first 5. And you can kind of build out your GraphQL query. What the greeting is, what the ID is, who sent the greeting, address was, and then we hit play, and there we go. We get that your Docker instance of the graph, and then you deploy your changes, and then you can start seeing them right away. So really cool. And then if we go back to where Scaffold ETH is here, we can refresh, and we should be able to see the data there at the bottom. There we go. So this is the example that we see on that subgraph tab. Graph.com. We have two prize categories. We have best use of the graph, which is first, second, and third place. And fourth place as well, I think. So first, second, third, fourth, and it's split up with different amounts. Then we have best substreams, which I'm not going to talk about today, but we can own subgraph. You can use the studio. So you go to Subgraph Studio. You can create a subgraph here. And this is going to give you all the examples. So if I put like example like this, create a subgraph, got one more minute. And I'm just going to answer questions outside. So that way we don't have to worry about taking up too much time. But here it gives you all the commands to spin up a subgraph. If you run these, it will bootstrap a subgraph for you. So you don't have to write it by hand on YouTube and cut the speed by like a quarter. And then you can watch it again.